Here, we are going to determine the initial or the terminal points of a vector u given the following situations. We have here the initial point, we have here the terminal point, we have here a terminal point and initial points. Take note that we can use the concept for initial and terminal points of a vector in determining its component using this formula. Let me write it here. So you have p sub 1, p sub 2. If this is your vector, is equal to, for R2, you have x sub 2 minus x sub 1, y sub 2 minus y sub 1. And for R3, you will have x sub 2 minus x sub 1, y sub 2 minus y sub 1, and you will have, you will have z sub 2 minus z sub 1. However, since this is now vector u, okay, let me make it bolder because this is a vector, okay, assuming that my what I did is correct. Vector u now is we'll be using rather these two formulas here, but since it depends on the given, since here the initial point is a, initial point here now that this is a terminal point, so we have different notations, so let's not use a or b, let me use x sub 2 and y sub 2. Now for our first given here, I don't know if my spaces are enough, but it's the vector u, which is the result. This is R2, so you'll have x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Since a here, point A is your initial point, these values of 1, 1 are your x sub 1 and y sub 1 values, okay? Because A is your initial point. And if we're going to place here the value of u, or the component for vector u, 1, 2 is equal to x sub 2 minus your x sub 1, which is 1, originally given, and y sub 2 minus 1 as well. So let us try to solve for the value of x sub 2 and x and y sub 2. And actually, we are solving here for the terminal point, okay? We're solving for the terminal point because it's the initial point that is given. So if we have something like this, we have equality of vectors, we can just simply say, let me use some spaces here, okay, x sub 2 minus 1 is equal to 1. Okay, this is what we mean by equality of vectors. That would mean your x sub 2 is adding both sides by 1, 2. For your y sub 2 minus 1 is equal to 2. This would mean that y sub 2 adding both sides by 1, you will have 3. So for the terminal point, for the first situation, with a component of vector u, which is 1, 2, initial point of 1, 1, your terminal point is at this component 2 and 3. So that is how we solve for a terminal point of a vector, of the vector u here given the initial point. Now what if we have the same vector u, but what is given now is the terminal point b? So it's just the same. We'll be using the same formula here for R2. You will have x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Your vector u has the components 1 and 2, but in this case, since b here is the terminal point, 2 and 0 corresponds to x sub 2 and y sub 2 respectively. This will mean your value here is 2 minus x sub 1, and you'll have 0 minus y sub 1. Okay? Same thing earlier, equality of vectors, you will have 2 minus x sub 1 is equal to 1, and on the other side, 0 minus y sub 1 is equal to 2. So you simply manipulate all these things. So let me transpose it here and this one here, and use symmetric property. X sub 1 is equal to 2 minus 1, which is 1. And again, transpose it here and here as well, and use symmetric property. Y sub 1 is negative 2. Okay? So because it would become positive y sub 1, minus 2, and then symmetric property. This would mean the initial point for the vector u with components 1 and 2, and its terminal point is at 2, 0. The initial point is 1 and negative 2. Okay. Now that we have the group already, let's proceed to R3. We just simply extend the formula as mentioned earlier. So our u here, let me make this bolder, is equal to x sub 2 minus x sub 1, then y sub 2 minus y sub 1, and we have z sub 2 minus z sub 1. And our vector u has components 1, 1, and 3 is equal to, here comes the thing, this is a point on the vector, which is actually the terminal point. So this corresponds to your x sub 2, y sub 2, and z sub 2. So substituting here, you have 0 minus x sub 1. You have y sub 2 is 2 minus y sub 1. And you also have another 0, and then minus z sub 1. And then again, equality of vectors. You have 0 minus x sub 1 is 1. Okay. You also have 2 minus y sub 1 is 1. And finally, you have 0 minus z sub 1, which is 3. So again, moving it here, and you will have here, transposing it, symmetric property, x sub 1 is negative 1. Transpose to make y sub 1 positive here as well. Its symmetric property, y sub 1 is 2 minus 1, 1. And finally here, transpose and transpose, you will have a result for z sub 1, which is symmetric property, which is negative 3. Okay, that's the result here. And then finally, for the last given, same formula, but since this is initial point, this corresponds to x sub 1, y sub 1, and z sub 1. So you will have your vector u with the components 1, 1, and 3 equal to x sub 2 is unknown minus negative 1. Okay, take note of the signs. And then you will have the next y sub 2 minus another negative 1. Then you will have z sub 2 minus 2. Okay. So you will have here 1, 1, and 3. This is x sub 2 plus 1, y sub 2 plus 1, and the same thing, z sub 2 minus 2. And again, equality of vectors, x sub 2 plus 1, okay, is equal to 1. So x sub 2 is 0. Then for y sub 2 plus 1 is equal to 1. So y sub 2 is another 0. And you have z sub 2 minus 2 is equal to 3. So z sub 2 is 5. Sorry, that's 5, not 1. That's 5. So for the terminal point, together with the initial point of negative 1, and 2, to make up with a vector u with components 1, 1, and 3, you will have 0, 0, and 5. So this is how we solve for either initial or terminal points of a vector. We given its component and a separate point. So we're solving for initial point given terminal point and vice versa. Thank you for watching.